Hello my dear students, welcome back to our lecture series of the chapter Some Basic Concept of Chemistry. In the last lecture we have discussed about the significant figures, scientific notation and almost all the basic concept. What is pure substance, what is mixture, what is homogeneous mixture, heterogeneous mixture, all these kind of things we have discussed. Today we are going to talk about the law of chemical combination. There are five important law of chemical combinations. The first one, law of conservation of mass, given by Anton Lavoisier, and the second one, law of definite proportion by Joseph Proust. Third one, law of multiple proportion by John Dalton. Fourth one, law of gaseous volume by Gay-Lussac, the Gay-Lussac law of gaseous volume. And the last one, the Avogadro's law. Other than this, we'll be studying about say law of reciprocal proportion, and we'll discuss about the Dalton's atomic theory as well. So first we'll start with the law of conservation of mass. We already know what is law of conservation of mass, right? Mass can neither be created nor be destroyed in a chemical reaction. That is what the law of mass conversion is telling us. Mass can neither be created nor be destroyed in a balanced chemical reaction or a physical reaction, but it can be transformed from one form to another form. We can transform it from one form to another form, but we cannot create, we cannot destroy this mass. So this is what we are calling this mass conservation law, law of conservation of mass. We can say that mass of reactants will be equal to the mass of products in a chemical reaction. In a chemical reaction, mass of reactants should be equal to the mass of product. If it is equal, then it is according to the law of conservation of mass. Then the second law what you have to discuss is about law of definite proportion, or we can call it as law of constant composition. What it is, let's find out. Irrespective of the sources, a given compound contains exactly the same proportion of element by weight. What? Just consider you are taking a water sample. You are taking a water sample from, let's say, Ganga. You are taking water sample from the Ganga. So that is here in this particular bottle. You got the water sample from where? You got the water sample from the Ganges, right? Fine. Then second, you are collecting another water sample. This water sample where you are going to Antarctica and you are collecting some water. Let's say if you get some water, you collect some water. You got two bottles. Here, this water is from Antarctica. So source is different. You got it from different sources, right? Yes. And irrespective of the sources, a given compound contains exactly the same proportion of element by weight. We'll check. We got 2 hydrogen. So what is the mass of 2 hydrogen? Is 2. We got 1 oxygen. What is the mass of 1 oxygen? 16. So what is the ratio? 2 is to 16. That is nothing but 1 is to 8. So 1 is to ratio combination is there in the water that is given from the river Ganges. Now, from the Antarctica, I took water. How much hydrogen? 2 hydrogen. Mass is 2. How much oxygen? 1 oxygen. Mass is 16. What is their ratio? Again, 1 is to 8. I took water from Ganga. I took water from Antarctica. But when I check the ratio of the weight of the elements inside that compound, it is same. That is what this law is telling us. A given compound contains exactly the same proportion of element by weight irrespective of the source. Whatever the source is, maybe if you are synthesizing some of the compound and that compound is actually naturally occurring, and if you are getting that particular, let's say calcium carbonate or CuCO3, whatever it is, so if it is that particular compound, then their composition is going to be same always. So according to this law, a compound can be obtained from different sources, but the ratio of each component by weight remains the same. You can take it from anywhere, but the ratio of component by weight will remain the same. It does not depend upon the method of its preparation or the source from which it is obtained. This is what we are calling as law of definite proportion. Fine. And the third one is law of multiple proportion. Let's find out what is this law of multiple proportion. According to this law, if two elements combine to form more than one compound, let's say two elements combine to form more than one compound, let's say it is producing two compounds, then the different mass of one element which combines with the fixed mass of the other element bears a simple ratio to one another. The different mass of one element which combines with the fixed mass of the other will be in a simple whole number ratio. I'll explain. So let's say we got two elements. Let's have two elements A. We don't have to take A and B, right? Yes, we'll take two elements as elements. Let's take carbon. Carbon is reacting with oxygen. Let's say we got carbon monoxide. How we are going to get carbon monoxide? Like this. Carbon is reacting with oxygen, you'll be getting carbon monoxide. So what is the mass of carbon here? 12 gram. What is the mass of oxygen here? Half O2, that is, we'll say 16 gram. And here, what is the mass of carbon monoxide? It's carbon 12, oxygen, carbon 12, oxygen 16, so it's going to be 28. That is not needed, 28 gram. Now look at that, carbon is combining with oxygen. What is the ratio? 12 is to 16 means 4 table, 3 is to 4. Fine. Now the same carbon is combining with oxygen to give you carbon dioxide. This time the mass of carbon is 12, mass of oxygen is 32 gram. So what is their ratio? 12 is to 32 means again 3 is to 8. So let's take a look at the ratios. Here the ratio is 3 is to 4. Here the ratio is 3 is to 8. Fine. What they are telling, if two elements combine to form more than one compound, two elements carbon and oxygen combine to form more than one compound, fine, the different mass of one element which combines with the fixed mass of the other element. Who got the fixed mass? Carbon got the fixed mass. So this is the variable mass. This variable mass, what they are telling about that, the different mass of one element. Here it is 16 gram, here it is 32 gram, 16 and 32, right? Right, 16 and 32. Fine, let me write that here. Okay, 16 and 32 grams. What they are telling, the different mass of one element which combines with the fixed mass of the other element bears a simple ratio to one another. What is their ratio? 1:2 ratio. Right, this is what they are telling. So you got the point. What is law of multiple proportion? When two elements combine to form more than one product, mass of one element which combines with the fixed mass of the other will be in a simple whole number ratio. This is what the law of multiple proportion. Now the next one is Gay-Lussac's law of gaseous volume. It's more, we can say that it is law of definite proportion by volume. We have discussed about the law of definite proportion, right? Law of constant composition, that we have discussed with respect to weight. Here Gay-Lussac's law of gaseous volume will be discussing with respect to volume. What it is? According to this law, in gaseous reaction, the reactants are always combined in a simple ratio by volume and forms product which is also a simple ratio by volume at the same temperature and pressure. If the temperature and pressure are same, the gases combine or produced in a chemical reaction in a simple whole number ratio of their volume. That is what they are telling. So when you got hydrogen reacting with oxygen, what you are gonna get? You will be getting water, right? So what they are telling us, if 100 ml of oxygen is reacting with 50 ml of 100 ml of hydrogen is reacting with 50 ml of oxygen, you will be getting 100 ml of water. So what is the ratio of volume they are combining? 2:1, and the product is also in the ratio with this one. So 2:1 is the ratio of this particular reaction. So So that is what Gay-Lussac's law of gaseous volume. When gases combine or produce in a chemical reaction, they do so in a simple Hall number ratio of their volume. They do so in a simple Hall number ratio of their volume, provided that it will be happening at the same temperature and pressure. Pressure constant argonum, temperature no constant argonum. Then the next one is Avogadro's law. You will be aware of this law, right? Avogadro's law. What is that? Equal volume of all gases under the same condition of temperature and pressure will contain equal number of molecules. This is that much simple, right? Equal volume of all gases under the same condition of temperature and pressure will contain equal number of molecules. Let's say at same condition of temperature and pressure, I am considering STP. What is the STP condition? Standard temperature pressure. So standard temperature, let's say the standard temperature is 273 Kelvin, and the standard pressure, let's say standard pressure 1 bar at this particular condition. So this condition is satisfied at same temperature and pressure. Equal volume of gases, let's say again I took two containers, one container, the volume is, let's say, 2 liter volume of this container. In this container I filled some gas, and another container 2 liter. But maybe if you look at this, maybe you will feel that this one is small and this one is big, but it's not. Both are of equal volume. Both are of equal volume. So let's say this is one 2 liter vessel, this is another 2 liter vessel. Here I am filling it with SO2, and here I am filling with CO2. So I have filled two gases in two different vessels. One is SO2, another is CO2. Both are having 2 liters of volume. The condition of temperature and pressure I have said you already, it is at STP. Look at the definition, equal volume of all gases. Now the volume of these two gases are equal, 2 liter. Same temperature and pressure is same temperature, same pressure. Will contain equal number of molecules. If the number of molecules here is n, then here also the number of molecules will be n. It doesn't matter what is the gas that is occupying the container. You got the point? Yes, this is what your Avogadro's law. So we have completed the 5 laws. We have discussed about law of conservation of mass. Then we have discussed about law of definite proportion. Then we have discussed about law of multiple proportion. Then we have discussed about the Gay-Lussac's law of gaseous volume. Then the Avogadro's law. Then let's take a look at the law of reciprocal proportion or equivalent proportion. What is that? When two elements combine separately with a fixed weight of third element. Two elements combine separately with a fixed weight of third element. Let's say fixed weight of third element. Again, I'm gonna make it reaction of carbon with hydrogen. So you got methane, right? So carbon mass is 12 gram, methane total 4 grams of hydrogens will be there. So it is combining, and you can see the ratio is 3:1. Fine, they are combining. Two elements combine separately with the fixed weight. Okay, I'm gonna make another reaction. Carbon reacting with oxygen, you will be getting carbon dioxide. Here the carbon 12 gram, oxygen 32 gram. So the ratio is 3:8. Fine. Now two elements, which are all the two elements? Let's say hydrogen, and hydrogen is one element, oxygen is one element. When these two elements combine separately with the fixed weight of the third element, separately fixed weight of the third element, which is having the fixed weight, carbon is having fixed weight. So two elements are combining with the fixed weight of the third element. Ratio of their weight in which they do so is either the same or a whole number multiple of the ratio in which they react. What they are telling is, carbon is reacting with hydrogen to form methane in a 3:1 ratio, and carbon is reacting with oxygen in a ratio 3:8. Now these two elements, if they are about to combine, 2H2 plus O2 gives you 2H2O. How they are going to combine? They are going to combine in this particular ratio, 1:8. 8 ratio. Let's check. See, 1 is to 8 ratio. This is the ratio they are going to combine. That is what they are telling. Not only this one, 1 is to 8 ratio or a whole number multiple of that ratio. So let's find out. 2, this is 4 gram, this is 32 gram. So 1 is to 8 ratio, right? This is what the law of reciprocal proportion is. When two elements are combining separately with a fixed weight of the third element, even if they are going to combine, they will be combining in this particular ratio, 1 is to 8. If you wanted to make it simplified, let's say if A combines with B to give you AB, and they are reacting in a A is to B ratio, and the same A is combining with C to give you AC in a ratio A is to C, and if this B and C is about to react, B and C is about to react to form BC, then they will be either combining in a ratio of B is to C or in a ratio of MB is to NC. That is what this law of reciprocal proportion is all about. M and N can be any whole number. Okay, fine. Now we'll be talking about the Dalton's atomic theory, then we'll be winding up. So we have discussed the all law of chemical combinations. Dalton's theory is the first theory that put forward by any of the scientists that accepted theory about the atom. You know that you might have studied that from your 8th or 7th standard about the Dalton's atomic theory. What Dalton is telling us, matter is composed of small large number of small particle which is indivisible, and he is calling it as atoms. Matter is composed of atoms which are indivisible, which are indivisible. That is what Dalton is telling us. Matter is composed of atoms which are indivisible, and he is telling that all atoms of one particular element will have same properties, will have same mass. We know that, yeah. Atoms of same element will have similar properties, and atoms of different elements will have different properties. Then they are telling atoms combines to form molecules in a particular ratio. But how atoms can combines? Atoms of different elements combines. Atoms of different elements combine to form molecule. That is how the Dalton is telling. But we know there are a lot of postulates that went wrong because the science is getting developed all the way. So we got many assumptions wrong, but still this is the first theory about the atom. Matter is composed of large number of tiny particles called atoms, and atoms of all the atoms of the same element will be identical in mass and properties. All the atoms of different elements will be different in its mass and its properties, and atoms of different elements combine to form molecules in a simple whole number ratio. Then they are telling that what is chemical reaction? It's just the reorganization of atoms or rearrangement of atoms, like that Dalton is telling. This is the basic thing that you can read it out from the NCRT. So this is all the things what you have to know about the law of chemical combination. That's it about the law of chemical combination. In the next lecture we'll be moving to the mole concept. We'll be discussing about the atomic mass, molecular mass, and all the kind of things. That's it for the session. Thank you very much.